Logarithm rules, as needed for chemistry. We need to know logarithm rules in chemistry because sometimes our equations have logs in them, and we need to get at the variable inside the log. Without logarithm rules, you're not going to be able to do that. We're not going to walk through every rule here, but I thought that I'd put them all here, and then we could walk through some examples of where you're going to very likely use them. You will likely not have seen the chemistry behind these examples that I'm going to give yet. Or maybe perhaps you are, and that's why you're here now visiting this video. But in this video, we are just going to focus on the algebra itself. And then you'll learn about the chemical concepts that lead to these equations in other videos and courses. This is just me kind of building a bridge between the math concept that you learn in some sort of algebra class and how this is going to be used in science, and why it's so important. Let's look at the following example to practice one of the rules. For the value given, I am asking what's the value of n? This is an equation that you'll run across in chemistry, but for right now all you need to know is that if you have all of the values except one, you can solve for the other one. I've also put up the applicable logarithm rule to help you with the problem. So pause the video, work ahead as far as you're able, and then come back when you have the answer or if you get stuck, and we'll work through it together. In order to keep the focus on the algebra, we're just going to solve this as numbers without units or without discussing the chemical properties behind the topics or the numbers. But note that this is a problem that you'll come across in chemical equilibrium. So pause now, come back when you know the answer or you're stuck. Okay, how did you do? Let's start by filling in what we know. So this step was just taking the numbers from the table and plugging into the equation. This gives us a little bit of room to solve and simplify just by moving the numbers around. So let's do that. Let's take the 5,298 that's on the right-hand side, divide both sides by that number, and then that will simplify quite a bit. And then we can take this middle number here and we can actually solve that for a value. And this gives us the following. Now, at this point, you might feel a little stuck. How do we solve for an exponent? Well, there's a few ways, but one of the easiest is to take the log of both sides. If we do this, then our calculator can solve for the left-hand side, and we can use logarithm rules to simplify on the right-hand side. So maybe if this is where you got stuck, now's the time to pause again and take the log of both sides and see how you do. Or we could just go ahead and keep going. So here I've taken the log of both sides. This will allow us on this side to solve for a value. On the right-hand side, we can use the logarithm rule as posted up in the corner to solve for the delta n. Because the delta n can move down here. This gives us on our left-hand side a negative 3.18, which is just the answer from plugging that into your calculator. And then on the right-hand side, we have that delta n log of the value, which we can also plug into a calculator. So now we can just divide whatever that log of 38.89 is over, which gives us negative 2. So in this case, our delta n would be negative 2. And this is a very common way that you'll use logarithm rules to solve for problems. It comes up quite a bit in chemical equilibrium and a fair amount in kinetics as well. Let's do another one. Speaking of kinetics. So let's look at this example. Again, you'll learn the chemical concept behind this when you cover kinetics in your chemistry classes. But for now, let's just solve the equation with numbers. You'll notice now that rather than a log, it's a natural log. The rules work the same regardless of what the base of the logarithm is, and so we can use that same set of rules that I listed on the first page for this one, and theoretically for other bases, though usually natural log and log base 10 are the two that we use in chemistry. Let's start the same way that we did our last one. Let's just put all of our numbers in. This is another place where you might want to pause, try this on your own, practice, and if you get stuck, come back. Or once you think you know the answer, come back. All right, so let's fill in. Here I've filled in all of our values, and then I've also gone ahead and since this side is just two numbers multiplied together, I went ahead and solved that just to clean that up all right away. Now, from here, we have something in the bottom of a logarithm. So there's a few different ways to go ahead and solve this, but I think that one of the easiest is to actually use the logarithm rule, where you split it out. So here, I've used the logarithm rule that I've shown up in the corner to place the logarithm into two separate logarithms. From here, we can just get this from typing it into a calculator. And then we can subtract that over and multiply by a -1 to move the negative over, and we're left with this. And then we can go ahead and use e, or the base of the logarithm, to the natural log to cancel that out to get e to the -1.66. E here is a number, right? E is one of the numbers that is represented by a letter, and you can find that on your calculator in various places depending on the type of calculator you have. And then this gives us our value. There are, of course, other ways to solve this one too, but I think that this is probably one of the easiest if you know your logarithm rules. All right, let's do one more example. The next example is going to bring us back to equilibrium. This one is going to be pretty similar to the last one that we did. It is a very common equation. It has a name. It's called the Henderson-Hasselbalch equation. You may remember that from somewhere back in chemistry. Otherwise, you'll cover it when you get to your chem classes. And we use this in equilibrium specifically involving buffers. So as with the other examples, for now, we're just going to focus on solving the equation, and we'll leave the chemistry for your chem classes. Let's start the same way we have before. Let's fill in our numbers. And as usual, pause and give it a shot on your own if you can. So we filled in our numbers. Now, probably the easiest way to go about solving this is to move the 4.68 over. So I would subtract the 4.68 from both sides. This gives us 0.06 log of a value with a variable in it. So we can't just do 10 to the power of necessarily, because it gets a little messy. I think it's easier to go through and separate out the logarithm. So if we separate out our logarithm, we would get log of 1.3 minus log of HA equals 0.06. We subtract the log of 1.3 over, giving us 0.0539 log of HA, and now we can very easily do 10 to the power of each one, right? So now we have log base 10, so we're going to do 10 to the power of each one to give us 1.13. This is another one where there are other ways to solve it, and that's okay. If you like the other ways, you can go for it. But I wanted to use this as an example of how to use logarithms to make it pretty quick and simple to do. So in this video, we solved for several equations using logarithm rules. And these are equations that commonly come up in the first year of chemistry and continues on into your second and beyond. We focused on the box rules in this video since these are the most commonly ones that we see in our first couple of years of chemistry, and that I think you'll find very, very useful in your chemistry careers.